Hello and welcome everyone in the tutorial video of Science Chapter 5 Matter and Chemical Formulae Part 2. You can pause and rewind the video if you didn't get any concept. To get most out of this video, please watch it till the end. So what all the contents we are going to cover it up in this video? Chemical formula, atomicity, valency, chemical reactions, chemical equations, balancing chemical equation, and a quick review of this chapter. We know that in all languages, alphabets combine to give words. The language of chemistry starts with the symbols. So what happens when these symbols combine? When these symbols combine, we get the chemical formula. Before moving into the topic chemical formula, let's see the elements and their valencies. On the left side, you can see the elements with the positive valencies, and on the right side, you can see the elements with the negative valencies. In this case, you will see hydrogen shows positive valency and negative valency. Similarly, carbon shows positive valency and negative valency. We know that carbon has 4 electrons in its valence shell. So, it can neither gain electron nor lose electron. It shares electrons. So, that is why we consider both plus 4 valency for carbon and minus 4 valency for carbon. So, now we will see in which case we take plus 4 and in which case minus 4, we will see that. Similarly, hydrogen completes its triplet structure by sharing 1 electron. So, that is why it has both positive and negative valencies. So, in which case we take plus 1 and in which case we take minus 1, we will see that. Water. It is a compound of hydrogen and oxygen. Hydrogen has 1 valence electron and oxygen has 6 valence electron. Now, in order to complete this triplet structure and octet structure, hydrogen shares the electron with oxygen atom. Hydrogen has valence electron, which is the doublet and stable structure for it. But oxygen is not satisfying its octet rule. So, it is not stable. In order to become stable, it needs 1 more electron. So, how does it do that? It uses 1 more hydrogen atom. So now 1 more hydrogen atom share its electron with oxygen atom. So now octet satisfies and the structure is complete. Now all the 3 are stable, which is represented as H2O, where 2 atoms of hydrogen and 1 atom of oxygen, and this gives the chemical formula of water molecule. To write the correct formula of a compound, you must know 2 things: the symbols of all the elements or radicals present in the compound and the valency of each constituent elements or radicals of the compound. The steps for writing the chemical formula of a substance are: write the symbols of all the constituents, that is elements or radicals. So, hydrogen is represented as H and oxygen is represented as O. So now, write the valency of each constituent below it. Valency of hydrogen is plus 1 and valency of oxygen is minus 2. Now we can write it as hydrogen with the superscript plus 1 and oxygen with the superscript minus 2. So now in the third step, cross the valencies and write them as subscripts. Let us illustrate these methods by writing the formula of water. We know that hydrogen has 1 valency and oxygen has 2 valency. Now cross this valency and write them as subscript. we get the formula that is H2O, which means two atoms of hydrogen combined with one atom of oxygen to form water molecule. Have you heard about atomicity? Well, what is that? Let's see. The number of atoms of an element that join together to form a molecule of that element is known as the atomicity of that molecule. Atomicity can be classified into four types, that is, monoatomic molecules, diatomic molecules, triatomic molecules, and polyatomic molecules. Monoatomic molecules are those molecules which contain only one atom. For example, sodium, zinc, magnesium, etc. Diatomic molecules are those atomic molecules which contain two atoms of the same type. For example, oxygen, nitrogen, chlorine, etc. Triatomic molecules are those molecules which contain three atoms. For example, O3, that is ozone. Polyatomic molecules are those molecules which contain more than three atoms. For example, phosphorus, sulfur. So you are now comfortable with the monoatomic, diatomic and triatomic and polyatomic molecules. Now you can classify these molecules very easily. Valency. Valency represents the combining capacity of the atom of an element. When we take the valency of hydrogen as 1, then the valency of atom or a radical may be defined as the number of hydrogen atoms that will combine with or be displaced by one atom of that element. For example, water contains two atoms of hydrogen combined with one atom of oxygen. One atom of oxygen has the capacity to combine with two atoms of hydrogen. Therefore, the valency of oxygen is 2. Valencies are always expressed in whole numbers. In this table, you can easily identify these valencies. Valencies of most elements fall between 1 to 4. Elements with valency 1 are called monovalent. Elements with valency 2 are called bivalent. Elements with valency 3 are called trivalent, and etc. Chemical reactions and chemical equations. A chemical reaction is a process in which two or more substances react together to form new substances. A chemical equation is a representation of a chemical reaction by using the symbol and the formulae of the substance involved. It shows which substances react and which substances formed. Water, a very essential substance for the survival of life. Let's look at this formation. Water is formed from hydrogen and oxygen. Formation of water, H2 plus O2. This gives H2O. So when H2 combines with O, it gives water. So such an equation is known as skeleton equation, which shows the reactant participate in the reaction to form the product. Now let's count the number of atoms in the equation. Hydrogen atoms in the reactant side is 2 and in the product side is 2. Well, oxygen in the reactant side is 2 and oxygen in the product side is 1. So in the last slide, does it mean one oxygen is destroyed? Is that really possible? No, it is not. Because we know law of conservation of matter states that matter can neither be created nor be destroyed. It can only change its form. So here in both the sides the equation is balanced Such an equation is known as balanced chemical equation. A chemical equation in which the number of atoms of each element in the reaction is equal on both the sides of the equation is called balanced chemical equation, which means the quantity of reactants and the quantity of products both should be balanced from both the sides. This is known as balanced chemical equation. Let's look at another example. N2 plus H2 gives NH3. You can see 2 atoms of nitrogen in the reactant side and 1 atom of nitrogen in the product side, which is not balanced. On the other hand, 2 atoms of hydrogen and 3 atoms of hydrogen in the product side, which is not balanced. So how can we balance it? We can balance it by increasing its number by 2. Now you can observe nitrogen is balanced from both the sides, but hydrogen is not balanced. Now we have to balance hydrogen. We multiply the H atom by 3. Now it is balanced. So this is a balanced chemical equation. So what do you observe here? You observed you can only increase the number, that is the number before the substances taking part in the chemical reaction. This means we can increase the number of molecules. The number of atoms present in any molecule is a constant number. This means one molecule of hydrogen always contains 2 atoms of hydrogen. We cannot increase or decrease the number of atoms. This is why we cannot change the subscript. What we can do is we can increase or decrease the number of molecules present in it. Let's look at a quick review of this chapter. The smallest particle of which matter is made of is atom. An element is a pure substance which cannot be broken into 2 or more substances by chemical means. A compound is a pure substance composed of 2 or more elements combined chemically in a fixed ratio. Mixtures are formed when 2 or more substances exist together without any chemical force acting between them. A chemical reaction is a process in which 2 or more substances react together to form new substances. In the third part of this video, you can go through with the questions and answers of this chapter. Thank you for watching this video. Till then, take care.